Right. What they say about the lights is true. So thank you. I'd like to start off by saying thank you to everyone who's made the Midnight Summit possible. I'm sure you'll agree it's been a fantastic inaugural event and that Midnight has some very exciting times ahead. I'm Fergie Miller, Director of Research Partnerships at Input-Output, and I'll be moderating the Fireside on Midnight's research foundations and future directions. I'm delighted to be joined by two of my colleagues from Input-Output Research, Professor Aggelos Kiayias and Elias Koutsoupias. Aggelos is Chief Scientist at Input-Output and Chair of Cybersecurity and Privacy at the University of Edinburgh, where he also directs the Blockchain Technology Laboratory, a leading architect of the Ouroboros Proof-of-Stake Protocol and recipient of the 2024 BCS Lovelace Medal. He's internationally recognized for advancing secure and scalable blockchain systems. Elias is a senior research fellow at Input-Output and professor of computer science at the University of Oxford, a leading worldwide figure in algorithmic game theory and recipient of the 2012 Gödel Prize. His work at I/O focuses on incentive structures, reward sharing, and strategic behavior in blockchain protocols. So this summit marks a major achievement for Midnight, but from a research perspective, the Midnight journey started 6 to 8 years ago. Aggelos, if I could come to you first. I know that IOR has published research across tokenomics, privacy-preserving transactions, and smart contracts, as well as a number of other papers, which has catalyzed the engineering that is being delivered in Midnight today. If you could think back to the beginning, could you tell us how Midnight came about, in your own words, and highlight perhaps the key research foundations that have informed Midnight?
Yeah, so this will take us back a number of years. It was about 8 years ago that we started this project on what we call proof-of-stake sidechains. So the question was, suppose you're given a highly decentralized proof-of-stake blockchain, and now you have another feature or another functionality that you would like to operate and have it being sprung up from this original chain. So you don't necessarily want to change the base chain, if you want to call it like this, but you would like to create a side chain that is going to inherit security from the main chain, but it can bring completely different features and functionality to the main chain. So this work led to the research of what we call proof-of-stake sidechains and the concept of what we call at the time merged staking. We were thinking ahead when we were doing this work, trying to understand how Cardano, as we were looking ahead and thinking Cardano will become a highly decentralized system, how is it possible that Cardano can grow and create a rich ecosystem where its community can experiment with new functionalities and ideas. So we laid this out. I mean, needless to say, the concept of a bridge was fundamental to this work because these new chains, let's say, that are created by developers trying new features are bridged back to the main chain. And then via the concept of what we call merged staking, these new chains would still be secure, because one of the hardest problems of a blockchain is to create a resilient backend, a resilient infrastructure. And the key point here is that if you are in an ecosystem like this, you could have the operators of the main chain, of the base chain, lend their support and run additional software that can support these new chains and functionalities. So this was all laid out in this work, which was very well received at the time. Still, we were quite ahead of the curve. I mean, as we are now, this goes back, let's say the paper was completed in 2016. We had the publication in 2017. Now we're like, about 8 years later. So that was, if you want, the foundations over which now we can have a system, an amazing system like Midnight. So that was the first stop I want to make. And then the second one was something that will bring us closer to, okay, what is the proposition, right? What is something, an important feature that could be explored in this context? And this is about privacy-enhanced smart contracts. It was clear that privacy is one of the key barriers for wide adoption of this technology. So there's no way that you can encode, let's say, all critical business logic in a smart contract platform and have this to be completely in the clear. There should be the capability of the system to enable you to make some elements of that business logic confidential, right? So that was clearly missing in Ethereum, was clearly missing in Cardano as well. The thing is that it's very challenging. The problem is that these are decentralized systems, and one of the key issues that you get, especially if you think about smart contracts, is that it is hard to deal with concurrent transactions. So concurrency is a natural issue. I mean, you expect people to engage concurrently with smart contract logic. And if you just go out of the box and you apply a zero-knowledge proof, and you have parties independently try to create these zero-knowledge proofs to prove that the state of the system can be safely transitioned to the next step, then if two parties come and do it concurrently, then you'll find out that applying these two operations will clash with each other if you don't do it carefully, and then it will be impossible for the system to absorb these transactions that are produced concurrently by different parties. So that's a big barrier. Interestingly, it's worth pointing out that this does not come, this is not an issue when you have a payment system, and that's why you had privacy-enhanced payment systems. But doing it with smart contracts is much harder. So this led us to the work of Kachina, the privacy-enhanced smart contract that was eventually led to the architecture of Midnight. So this is the two works that, basically, if you want, cover the consensus and cryptographic part. But another important topic is about incentives and the cost model of accessing a system like that. And this brings me to the topic of space tokenization, for which is work that, we've worked together with Elias on that, and I think he would have a lot of things to say about it as well.
Sure, Elias, could I bring you in here? This is an area of your expertise.
Yeah, so our paper on tokenomics and ongoing research explores the question of predictability and responsiveness. Traditional blockchains like Bitcoin focus on responsiveness. If somebody is willing to pay enough, their transaction will will be processed quickly. Midnight takes an opposite, not exactly the opposite, but somewhat opposite direction. It cares about planning. You pay in advance so that you have predictable service in the future. You get a minimum future service, and you don't have to pay anything else. And Midnight does both things. It's a little bit responsive, and it's a little bit predictable. And the question is a great question: is whether these kind of mechanisms can achieve both worlds, can be good in both worlds, be predictable for those that plan ahead, and be responsive, have responsive service for those that are willing to pay immediately.
Great, thank you, Elias. And I know game theory permeates across all aspects of system design. What, in respect to Midnight, would you say are the key aspects of incentivization and strategic behavior that are unique to Midnight?
I'm not sure that I got your
With sort of what sets Midnight apart from other protocols? Is it things like
For tokenization?
Yeah, from a game theory perspective, but also from a tokenization perspective,
okay. Yeah.
sort of things like robustness or sort of other aspects of design.
So how does game theory come into the picture? Let's take Midnight. Midnight has this novel mechanism of 2 tokens. Dust is, you pay transactions with dust. Dust is not tradable. You cannot sell it. And this creates a completely new environment and raises a lot of questions. So how users are going to react to that? And it's an open question we're going to see in the future. And from the game theory perspective, this is more, okay, let's say that this is more about beyond behavioral economics. It's not about human nature, because people explore, users explore, participants explore many strategies that we haven't considered in advance. It's not possible to consider all of them, and therefore the protocol must be robust. In other words, it must work as expected, even if the users, the participants, try unexpected strategies. And this requires a very good design, a simple, robust protocol that can withstand any kind of unusual user exploitation. And Midnight is a perfect ground to understand this kind of questions, to explore how a protocol can be robust, even if you cannot really predict the future, how it's going to behave in the future.
Great. And Aggelos, I know I want to sort of ask you a bit about Minotaur. So that's a very other sort of notable area of research that we've done at Impact Output. Could you sort of talk about its relevancy to Midnight?
Yeah, so this fits well with what Elias was saying. So there are a number of features that the Midnight blockchain brings. I mean, the one we discussed already is the 2 tokens. So, by the way, from the tokenomics perspective, we had a breakthrough result that we published last year, but was presented at a conference, The Advances of Financial Technology this year, which basically demonstrated how 2-token proof-of-stake systems like Midnight give a much more agile and capable design space for tokenomics policies, what you might call monetary policy for blockchains. So these 2-token systems, they give you a lot more opportunity to do things and extract useful properties about how the tokens behave, how the prices of the tokens behave. So they are much richer platforms and fertile ground for mechanisms, as Elias was saying. So this is the 2-token feature that it's a very innovative direction that Midnight is taking. And the other innovative direction, which is also comes in some sort of multiplicity, is coming through the Midnight airdrop, which is a very large-scale cross-chain airdrop to different systems, which opens up the opportunity to think about a future of Midnight that could be a multi-resource consensus engine and platform. And just to appreciate a little bit about this multi-resource functionality, if you look at systems like Bitcoin, Ethereum, and Cardano, and so forth, these are all single resource systems. So basically, they base their consensus engine on a fundamental resource, be it computational power or stake, and their security is drawn from that. But the Minotaur work that you mentioned, work that we published inspired by the bigger Midnight vision 3 years ago, talks about how is it possible to create a consensus engine that draws its security from multiple resources. So the Minotaur paper was exploring one particular configuration of this, which basically was asking the question, can I take work and stake and create a compound resource? You can think of it as work stake, and then base the security of the protocol on that compound resource. And this is the question that it was open, let's say, to do it properly up to our work, and that was solved with the Minotaur paper. And of course, thinking about this and the techniques that we developed there now open up the direction for thinking of multi-resource in a context of multiple stake-based resources. So you can think of basically a platform that draws security from Bitcoin, Ethereum, Cardano, and different systems, pulling resources together and essentially breaking these somehow island barriers that you have when you look at these ecosystems today, right? So the future of what Midnight can be, with its emphasis of bridging of bridges, because it fundamentally begins with a bridge to the Cardano ecosystem, but thinking about the bridges that it can build via the airdrop, but with further bridges to these systems, for example, bridges back to Bitcoin, which is a very active area of research at Input-Output right now. It opens up opportunity from drawing resources from different systems and securing these platforms, securing blockchain platforms, and Midnight in particular, by many different resources that can be pulled together.
Sure. So you're beginning... Sorry, Elias, would you like to add to that?
I think the underlying issue here is mechanism design. And we heard a lot about privacy, rational privacy here. And rational privacy is about disclosing information. A traditional theory, a major theory in game theory, is mechanism design, which deals exactly with this issue of disclosing information. For example, in an auction, people have private information, how much they value an item, or multiple items. This is a multidimensional mechanism design, actually, that Aggelos mentioned. And disclosing this information having this private information has an advantage. You can get better prices if you have private information, because in some sense, the auctioneer pays something to get this information out of you. That's an important aspect of how Midnight, that has a new layer of privacy, is going to be the ground of designing new mechanisms.
Great. Well, I know MEV is a sort of an active area of our research amongst a number of others. Aggelos, you were starting to talk about the future, so maybe I could come back to you on that. And you know, one of the sort of aspects of research is it has this long arc nature, which at times can make it a more nuanced story to tell. Today is a very significant milestone for Midnight, but in one way we're very much at the beginning. Could you speak to a bit about what research directions you believe are required for Midnight to continue to lead in rational privacy in other areas, not just over the next few years, but over the next 5, 10 years, maybe decades?
Yeah. So looking ahead, there is one direction which is quite important from a safety perspective, and that's post-quantum security. Now, the fact is that a lot of the cryptographic techniques that are in play here, including in systems, Cardano, Ethereum, but Midnight as well as we speak today, they're not safe from an adversary that is equipped with a quantum adversary. So the question is, in which way we can draw from novel cryptographic techniques that can be resilient against quantum attacks. And the direction that we're moving is the direction of lattice-based cryptography that has the following important advantage from this perspective. So lattice-based cryptography not only is capable of withstanding quantum attacks, but also it unlocks additional cryptographic capabilities that are impossible, as far as we know, with the more classical cryptography that is used in these systems. And just to highlight how important this is from the perspective of Midnight, using lattice-based encryption mechanisms, it is possible to have private state created by different sources interact meaningfully with each other. So these are the same techniques that have been used in the context of fully homomorphic encryption, where basically it's exactly what's happening, right? So these are like encrypted information coming from different sources, but then it is possible to compute functions on top of that encrypted data and calculate the outcome. So this opens up a lot of opportunity in the context of Midnight, because we want to be moving to a setting of smart contracts that enable users to interact with each other's private state in a complex fashion. And what we would like, ideally, is to be able to run any type of business logic in a platform like Midnight that is privacy enhanced. And this goes back to the point that Elias was making, that Midnight, in this way, should be transitioning to a safe platform where absolutely any mechanism could be developed as an application on top of the platform. And of course, maybe speaking about mechanisms, of course, it's one feature to think about people being able to design mechanisms, but they have to be also get the incentives right. And I think, like, for this reason, not only cryptography is very important to get right, but also understand the game theory aspect.
Yes, that's game theory permeates all these systems, and it's a great research area to understand many of things. For example, pooling, who have traditional blockchains like Bitcoin or Ethereum or Cardano, they have pools. Some of them are on-chain, some of them are formed off-chain. This creates incentives, unpredictable incentives. We couldn't probably predict this in advance. So game theory tries to understand what is going on, what will happen when we design systems. We just design protocols, and at the end, you have a game theoretic issue. Understanding it is a great question, and Midnight raises many, many interesting long-term research questions.
Great. So we've got about just over a minute left. Any sort of concluding remarks on the research side?
Well, I mean, the thing I can say is that it's incredible to be here. It's incredible to be here with all of you people that are interested in this technology. I have to say, looking back, when I was a PhD student and we were, writing in a blackboard some of these zero-knowledge protocols or multi-party protocols, it would have been in my wildest dreams that I would have imagined that this type of technology can reach out and make such an impact, and hopefully much more in the future with the help of all of the people that are here and in other blockchain communities, bringing this technology to the world to solve real problems. So this is why I think it's an amazingly exciting moment right now, and I would definitely be looking forward to more of that.
Elias? Okay.
I second that.
Great. Well, thank you for your time, Aggelos and Elias, and thank you for those insightful thoughts. I hope we've all come away a bit wiser after the session. We'll be around after Fahmi's closing session, so please come and find Input-Output Research over lunch to discuss how our scientific research can support you create the future in privacy. So thank you. Enjoy the rest of your day.